This lecture goes over a real-world example of how to apply C++'s exception handling mechanisms to a C++ program. And the example is contained in the exception handling notes. The example we will be using is a so-called safe array that's going to ensure that we can't have that where subscripts cannot be out of bounds in the array, that we cannot allocate zero size or negatively sized arrays. So we're going to have a few runtime checks to make sure that the user doesn't commit any errors. So the first thing I did was I created an array exception class as my base class for array exceptions. And you see that I've declared my own response method, made it pure virtual. So array exception is an abstract class. I've now defined an array size exception that will be thrown if the user enters a negative number or 0. And as you can see, I'm taking a single parameter, which is the erroneous size, and storing it in a size variable. I'm also providing a default response, which is to print an error message that says the array size of whatever was passed in is negative. Then I have a second one for when the array index is out of bounds, and I'm keeping track of two pieces of information, the index and the size of the array. And so when I create the array exception, I need to pass in both those parameters. And in this case, I've chosen to provide an empty method body for response. I had to provide some method body if I wanted this to be a concrete class. I've chosen to force the user to do something about it. And finally, I just for kicks created an out-of-memory exception that would be a more general one if new failed for any other reason. Now I realize we did just go through a example of this on the end of the lecture, which is that the standard template library has a predefined exception for this situation called bad alloc. But just for explanatory reasons, I have my own out-of-memory exception class. So now I declare my class safe array, and it's got a dynamically allocated array of data plus size. And here's my constructor taking a default parameter of size 10, but the user can override that. You can see that the first thing we do is that we check to see if the size is less than or equal to 0, and if it is, we throw an array size exception. Notice we do not have to have a try block because we are not trying to catch anything here. So it's permissible to throw an exception and not have it be within a try block. We only need a try block when we're trying to catch exceptions. So as long as S is positive, we try to allocate the array. And if for some reason that fails, we throw an out-of-memory exception. Now, in fact, this was written a few years ago, and right now what would presumably happen is C++ would raise a bad alloc exception here, and I would never even get to this point of the code because the new operator would raise the bad alloc exception. But if for some reason I was running, say, an older compiler where that wasn't the case, then if the new failed and returned 0, I would explicitly throw my own out-of-memory exception. And finally, I simply initialize the array. Now moving on to my set and get methods, you see that I have range checked the index before I actually either assign a value or return a value. And down here, my range check method makes sure that the index is in range. If not, it throws an array out of bounds exception. And note that it's thrown it's a stack allocated object. And you'll also know that, note that in this case it's inside a try block because I've decided that I want to catch the exception if it occurs. And in this case, I am printing out an error message, and then I am rethrowing it. Okay, and you'll notice also that I made this range check protected. This is good practice because range check never needs to be called by a user. This is a helper function that's just doing range checking for my getter and setter methods, and therefore it's a good idea to make its implementation be protected. Finally, we have a little driver for testing out my safe array. You can see I'm creating a pointer version of it, so I'm going to be allocating it off of the heap. So I put the potentially error-prone statements into a try block. So I first try to allocate one, then I try to set the third entry to 10, and then I try to get the value of the -1 entry, which is going to presumably give me an array out of bounds exception. So you can see, first of all, that I'm catching a out of memory exception, and the const is often good form because if I'm not modifying the formal parameter for both documentation purposes, compiler optimization purposes, it's good to have it. And in that case, I print that there was an out of memory error, and probably it would be a good idea to exit at this point. I have not done so here, but continuing is kind of fruitless. And then we also have my out of bounds exception, and you can see from this statement right here that that exception is for sure going to get triggered by get. Remember, the range check method is called from get. Range check is rethrowing the error condition right here, and therefore it's going to get caught down here where we're going to print index out of range and saying that it must be between 0 and whatever the size is, and you can see we're using two of the instance variables from this exception. Now, to show that we can continue executing if we use the catch clause to repair the problem, we are going to continue here. In fact, there was no damage done by trying to get a bad subscript. We just printed an error message. So now we're going to iterate from -2 up to 100, and we're going to set that index location that I currently has to I, which it should be pretty clear from -2 and -1 should raise exceptions from set because it's out of bounds, so it will be caught by this particular clause. And because it will be caught, execution will continue at the first statement after the catch clause, last catch clause, and that's right here where my cursor is. And because that's the end of the for, it just goes back up to the top of the for loop and increments I and continues on its merry way. You can see in the middle of my for loop, I try to allocate a new safe array, but because it's -10, that's going to get me a array size exception error. You'll notice that's not in this list, but because array exception is a superclass of array size exception, it will be caught right there, and we're using the response method to handle the response. And finally, you can see that because I went up to 100 with the less than equal, that's also going to give me an error at the end because 100 is going to be out of bounds. So just looking at what gets executed, you can see that first of all, the array out of bounds right here that is catching anything is printing caught it. So when I say get -1 right here, that's going to correspond to this caught it, and it's going to say that -1 is out of range, must be between 0 and 100. And that's because of this second catchphrase. Remember, we re-threw the exception, so first we print caught it. The throw then comes out to here, is caught here, and we also print index -1 is out of range. The next two messages are from the for loop where we started at -2 and -2 and -1. In fact, the caught is right here. So it is, these are the two error messages that get printed, one for -2 and one for -1. Then remember, halfway through we tried to allocate a negative sized array, and you can see that what gets printed out is the array size of -10, and you can also see that it was an array size error. It was a virtual method, and because I'm passing it by reference, it is invoking the virtual method for that was defined for array size exception. If we go back up here to array size exception, you'll see that we defined its response method to print out the error message, the array size of such and such is negative. Hence, down here, we get the array size of -10 is negative. And finally, at the end, we went out of bounds with 100, and that one got caught as well. The last thing I've done is I have prepared a couple experiments to show you certain things, traps that you have to be careful with exception handling. The first one is a very simple program to show you what happens if you throw an exception that doesn't get caught. So here I am throwing a STD exception, and by the way, this throw right here is just telling the C compiler that we are not handling the exception, but instead we're throwing it out of main, and we do that with the throw keyword and then with a comma separated list of exceptions inside of parentheses. This was deprecated as of C11, and therefore with the new C11 standard you are not supposed to use the throw statement anymore. However, you'll often see it in legacy code like this. At any rate, we're saying that we're throwing the exception but not handling it, and if I run it, you'll see that it was caught by the dynamic library, and it just says terminating with uncaught exception of type STD exception abort trap 6. So this dynamic library will catch any exception that you do not catch. Okay, a few other traps. Remember I said that you cannot define or use within a catch clause anything that you define within a try. So let's go into our main and show that. So we're going to try to declare int I equals 10. And then let's go to our catch clause for the array out of bounds and try to print out I. You're going to see I'm going to get an error message that's going to say I is undeclared because it's in the try and not outside of it. So doing so gives me the error I undeclared. Another thing that's important is where you put Another thing that's important is where you put the try block. In my for statement, I was careful to put the try block inside the for loop. If I had put the try block outside the for loop, then the for loop would have not executed again once some exception was triggered. So to show you that, I am going to move the try outside of this loop. And I'm going to have to move these catches also outside. So these catches are now outside of the loop. And you'll see that now the very first error I make, which is going to be the -2, is going to cut off the loop because the loop is inside this try block. Once it's caught and handled by this array out of bounds catchphrase, execution will pick up after the try block. There's nothing there and the program will end. So now I compile it and I run it, and you can see that now the program got terminated as soon as the first error in the for loop was caught. So this concludes our discussion of C++'s exception handling. We will consider Java's exception handling in a separate video lecture.